Okay, everybody, we are going to be doing the homework, and we're going to be using our flip book that we made in class, so hopefully you guys have this here at home as well with you. This worksheet, notice it's talking about, hang on, let me close this window. If you hear people running around, I'm at home. Notice it's talking about parallelograms, so we're going to be using the parallelogram tab of our flip book. But remember, parallelograms are also what? When I lift it up, what else comes with it? Well, quadrilaterals. So a parallelogram has the properties of a quadrilateral as well. And the only property we're really focused on with quadrilaterals is, one, has four sides, and two, that the interior angles all sum to 360 degrees. And we get that through that n-2, the sum of the interior angles formula. So as I'm thinking about this particular assignment, I want to make sure you really are just focused on this page. Now, what are the properties of a parallelogram? Well, we know the opposite sides are parallel. We know opposite angles. So this angle is congruent to that angle, the ones on opposite sides of the shape. And we also know opposite angles here are going to be congruent as well. We also know that the diagonals bisect each other, opposite sides are congruent, and consecutive angles, so 1 plus 2, those two angles together are going to add up to 180. We also know if we had a third angle over here, we know they're opposite, so they're going to be congruent. So 1 plus 3 would also be supplementary as well, because 2 and 3 are the same measure. Now, we're not going to be using this particular function right now, or this idea. We're going to talk about that in another day. I just wanted it here because it's an important thing for you to remember as we move into proving that parallelograms are parallelograms. So let's look at this first one, and hopefully I'm zoomed in enough for you. But as I look at this one, I notice here that I have an angle here and an angle here. So I have a pair of consecutive angles. Now, consecutive angles are what? Another place you can look, if you're still not positive, is remember this front page. It tells me that consecutive angles are supplementary. And everybody should have all of these. If you don't, make sure you go onto Blackboard and print it out for yourself. So I know that these two angles are going to be supplementary. Well, what the heck does that mean? We know that x plus 130 equals, well, what does supplementary mean? 180 degrees. So when I subtract, I know I'm going to subtract 130 on both sides, and I know x is equal to 50 degrees. So that angle right there is 50 degrees. I also know, if you look, remember we have opposite angles that are congruent. I know this angle over here is 130. And I know that this angle is 50, because we just found that. And that means that this angle is also 50. So finding a couple of angles in a parallelogram is very helpful to what we're doing. Now, I want you to think about that when you're doing number 3. Number 3 is just as simple, different idea. In this one, we're talking about a different type of angle pair. I particularly want to look over here at number 2. In number 2, what are we talking about here? Notice that this 5x plus 2 is in the middle of this side. So that is referring to this side here. And we know that that is going to be congruent to this side. How do I know that? Well, when I go back to my list of properties of parallelograms, remember we said that opposite sides are congruent. Well, when I say congruent, you think equal, remember? So it's 5x plus 2 equals 6x. And then you're just going to solve that for x, which is pretty simple. We're going to subtract 5x on both sides. And I know that x equals 2. Now, notice that in my directions, they just want me to find x. But had they want me to find the length of this side, what would I have done? I would have come and subbed in that 2 that we just found down here for x into the problem. So 5 times 2 is 10. 10 plus 2 is 12. So I know the length of that side is 12. Okay, same kind of similar problem down here at number 4. Number 5 and number 6 are similar problems as well. So I'm just going to choose to do number 6 for you. I'm going to do number 6 because I think it's harder than number 5. I haven't done both of them, but they look very similar. But what are we talking about in this picture? What is the name of this kind of a line that goes from one vertex to another? It's called a diagonal. And what do we know about diagonals in parallelograms? Remember, that's what we're focusing on, is parallelograms. A diagonal in the parallelogram, we know that the diagonals bisect. So I want to make those marks on my shape so I don't forget what I'm doing here. I know this piece is congruent to this piece, and this piece is congruent to this piece. That's a pretty tough question, isn't it? Do I have any of them that have just the same variable? Doesn't look like it. So what are we going to do here? Well, if this was a rectangle, we'd know that the diagonals are congruent, but we don't know that here. So, hang on a second, I've got to check on something.